LangGraph's interrupt mechanism enables dynamic execution pausing within graph nodes, allowing external input to influence workflow progression through conditional state transitions. This artifact demonstrates how improper handling of conditional interrupts can disrupt execution order and state consistency. We are about to examine a node implementation where interrupt sequencing becomes non-deterministic due to conditional logic, revealing the critical importance of maintaining consistent interrupt ordering across execution cycles.
Def node state. Hash bad. Conditionally skipping interrupts changes the order. Name equals interrupt. What's your name? Hash on first run. This might skip the interrupt. Hash on resume. It might not skip it, causing index mismatch. If state, get needs age. Age equals interrupt. What's your age? City equals interrupt. What's your city? Return name. Name city.
This code demonstrates a critical pitfall when using conditional interrupts in LangGraph nodes. The pattern shows how conditionally skipping interrupt calls can break the execution flow during resumption, causing index mismatches in the resume value list. The issue arises because LangGraph maintains a strict index-based matching system for interrupt calls within a node. When execution resumes, the node restarts from the beginning, and each interrupt call expects to find its corresponding resume value at the same position in the list. By conditionally including the age interrupt based on state, get needs age, the code creates an inconsistency. The first execution might skip the age interrupt, resulting in 2 resume values needed, while a resumed execution might include it requiring 3 values, causing a mismatch. This approach violates the fundamental rule that interrupt calls must maintain consistent ordering across all executions of the same node. The solution would be to either always include all potential interrupts or restructure the logic to avoid conditional interrupt calls entirely. The pattern highlights why interrupt ordering must remain deterministic for reliable graph execution, especially in human-in-the-loop workflows where resumption is common. Let's break it down.
Def node state
defines a function named node that takes a single parameter, state, with type annotation state. The function signature indicates it expects a state object as input, but doesn't show any implementation or return value in this segment.
Name equals interrupt. What's your name?
Calls the interrupt function with the string argument, "What's your name?" and assigns the returned value to the variable name. The function appears to prompt for user input, as suggested by the question format of the argument, and the result is stored in name for later use.
If state, get needs age. Age equals interrupt. What's your age?
Checks if the state dictionary contains a key needs age with a truthy value, and if true, calls the interrupt function with the string "What's your age?" to presumably prompt the user for their age. The result of this interrupt call is then assigned to the variable age.
City equals interrupt. What's your city?
Calls the interrupt function with the string argument "What's your city?" and assigns the returned value to the variable city. This suggests the function prompts the user for their city and returns the input, though the exact behavior depends on the interrupt function's implementation.
Return name. Name city.
Returns a dictionary with 2 key value pairs. Name mapped to the value of the name variable and city mapped to the value of the city variable. This is a simple data structure creation that packages these 2 values together for return from the function. Conditionally skipping interrupts breaks LangGraph's index-based resume system. The node starts with a name interrupt, then conditionally adds an age interrupt based on state, followed by a city interrupt. On first run, if needs age is false, only 2 interrupts fire. but on resume with needs age, true, 3 interrupts are expected, causing an index mismatch. The core issue is that interrupt ordering must remain deterministic across all executions. The solution requires either always including all potential interrupts or restructuring to avoid conditional interrupt calls entirely. This pattern highlights why interrupt sequencing must be consistent for reliable graph execution, especially in human-in-the-loop workflows where resumption is common.
The state remembers the interrupt it never called, while the graph forgets the answer it already wrote.